Let's say you need to find the sine of negative 405 degrees. First thing to do, we want to find reference angles, and I'll talk about that as I go through this problem. But first, let's look at coterminal angles. And in this case, what I want to do is I want to get an angle that's in between 0 degrees and 360 degrees. And I can do that by either adding or subtracting a full rotation, which in this case I could add 360 degrees. And that'll give me an angle that falls in the same spot, which means I can use it to evaluate sine of that angle. So negative 405 degrees plus 360, that is negative 45 degrees. So you could find the answer at this point. I'm going to go ahead to just get it between 0 and 360, and I'll kind of show you how you could use it either way. So now let's say if I added another 360 degrees, I get 315 degrees. I'm just going to highlight both of these. All right, so once you've kind of narrowed down where that angle is, got it to be a smaller number essentially, then I'd say to go ahead and try and draw it and figure out which quadrant it falls in. So in this case, I usually mark them 0 since it's in degrees. I'll leave it as degrees here. 180. So first, if I look at it from the perspective of 315 degrees, well, 315 degrees is in between, fix this, 270 degrees and 360. So that tells me that this angle falls in quadrant 4. The reason that I was saying you could also use the negative 45 degrees is that a negative rotation means instead of going counterclockwise, you go clockwise 45 degrees, and it actually ends up in the same spot. And also to see that now I actually want to move on to finding the reference angle. So I'm going to find the reference angle just as if I was working from that 315 degrees. So I know this is 315 degrees. The reference angle, once you find which quadrant it's in, the reference angle is always the angle between that original angle, in this case 315, and the x-axis. So I'm going to go ahead and write that down. And a couple things to remember about a reference angle is that it will always be positive. And it's always acute, which means less than 90 degrees. So depending on which quadrant it falls, that's how we determine the reference angle. In this case, since I want the angle here, it's like I'm really looking for the difference between 360 degrees and 315 degrees. So if I subtract that, I get 45 degrees. So this is the reference angle. And the whole reason we figure out this reference angle is so that it might relate back to one of those special triangles. So this tells me that if I draw a triangle here going back up, that it's going to be based off of this triangle right here. So I'm basically just going to take that triangle and draw it right into quadrant 4. So to draw the triangle, the 90 degrees, in this case, goes out to the right. The angle's 45 degrees, and we talked about how it's 1, 1, and square root of 2. So the only thing is, this is why knowing where the reference angle falls, meaning which quadrant, is important. Because this fell in the 4th quadrant, my x is positive, so that adjacent value should be a positive 1, but I went down in the y values. So this would be opposite would be represented by a negative 1. The hypotenuse is always positive, so I leave the square root of 2 alone. Now I go back and it's like, well, what was I originally looking for? So let's see here, we wanted to know what is sine of negative 405 degrees. So to remember, sine of an angle is opposite over hypotenuse. So now we'll write the final answer. So opposite in this case is -1 over the hypotenuse is square root of 2. So you can go ahead and leave your answer like that. If you want to rationalize the denominator, you can multiply the top and the bottom by square root of 2, and that gives negative square root of 2 over 2. And now I want to do another problem. Same thing, finding the reference angle, but using radians instead. Let's say we want to find the value for cotangent of 23 pi over 3. First thing is coterminal. In this case, I'll try to get an answer that's somewhere, or that is between 0 and 2 pi. So you can add or subtract a full rotation. So a full rotation in radians is 2 pi. But a lot of times what you need is a common denominator. So in this case, since my angle has a denominator of 3, you can write 2 pi as 2 pi over 1 and multiply by 3 over 3. So a full rotation is the same in this case as 6 pi over 3. And now I can go ahead and subtract 6 pi over 3 from the original angle to get an angle that's smaller, but still lands in the same spot as 23 pi over 3. So we'll subtract 6 pi over 3. I'll subtract again. And again. And this is where I'm going to stop, because if I subtract any more, it's going to become a negative angle. So here I've got 5 pi over 3. Now I need to figure out which quadrant it falls in. So if you want to, you can always convert it to a degree. I just like to keep it in radians sometimes because as you move forward in your math classes, usually the angles are always going to be in radians, so it's good to get a little familiar with them. And the main thing with working with radians is really getting common denominators. So first thing I'm going to do is label all the 90 degrees so I can figure out where the angle falls. But here the thing is, it's hard to compare, like 5 pi over 3, how does that compare to 3 pi over 2? So you could actually get a common denominator with everything here. And what I'm actually going to do though, because for example, pi could be rewritten as 3 pi over 3, but when I have those pi over 2 and 3 pi over 2, I actually try to find something, a common denominator between 2 and 3. Which in this case, the common denominator would be 6. So I'm going to write 5 pi over 3 instead, multiply it by 2 over 2. That's the same thing as 10 pi over 6. And if I convert all of these, the 2 pi I can multiply by 6 pi, or just 6 over 6. So that's 12 pi over 6. And then just get common denominators all around. So I've rewritten my angles in radians as 0, 3 pi over 6, 6 pi over 6, 9 pi over 6, and 12 pi over 6. And I think this makes it clearer to figure out, well, where does 10 pi over 6 fall? I mean, essentially, you can just ignore the pi's because they all have a pi. And you could say, well, where does 10 over 6 fall? Well, it falls between 9 over 6 and 12 over 6. So the angle, again, is going to be in quadrant 4. So that's rotating around. 5 pi over 3, which is the same thing as 10 pi over 6. And I haven't written the angle in here yet because that angle that I want to find now is going to be the reference angle. So to find the reference angle, I can take the 2 pi minus 5 pi over 3. But really I want it to be in common denominator form, which we've already written. So that's the same thing as 12 pi over 6 minus, well, maybe I don't want to deal with the denominator of 6 anymore. So I'll just write that as 6 pi over 3 minus 5 pi over 3, which is pi over 3. And you may have noticed a trend, which is that a lot of times what's nice about radians is you can really just look at the denominator, and that helps you figure out what the angle is going to be at the end. Is it going to be a pi over 3? Is it going to be a pi over 6? But the work to find the reference angle is important to figure out which quadrant it's going to be in. So here we've got a reference angle of pi over 3. And if we go back to those angles or triangles from the beginning of the video, that's going to be the 30, 60, 90 triangle. Since pi over 3 is the same as 60 degrees, that's the larger one. So that side has the square root of 3. This one's the 90, so the 2 goes here, and then we've got the 1. Now I'm going to look at the x and y stuff. So x's are positive, so that's a positive 1. Y's are negative, so that's a negative square root of 3. Hypotenuse is always positive, so that stays a 2. What were we looking for? We wanted cotangent of this angle. So cotangent of 23 pi over 3. Remember that cotangent is equal to adjacent over opposite, or the reciprocal of tangent. So that would be a 1 over negative square root of 3. So that's the answer. Or if you wanted to rationalize the denominator, you can multiply the top and bottom by square root of 3. So that's also square root of 3 over negative 3.